Now discuss 15th question from exercise 15.1. 5 cards. Those are the 10, Jack, Queen, King and Ace of diamonds. All these are diamonds. Okay? The 10, Jack, Queen, Kings and Ace. 1, 2, 3, 4, 5 of diamonds are well secured with their face downwards, means kept face downwards. One card is then picked up at random by using this information. First question is, what is the probability that the card is the queen? The card is the queen. First one. Second question is, if the queen is drawn and put aside, means taken and kept aside, what is the probability that the second card picked up is, after removing the queen outside, the second card picked up is in this first one, an ace, B, a queen. So these are the questions we have to write. See, solution. Total number of cards are 5 because 10, Jack, Queen, Kings and Ace of diamonds. All these are diamonds. Total number of cards are 5 here. First question is, probability of getting queen is number of favorable outcomes divided by total number of outcomes. So how many queens are here in the given number of cards? 1 queen. Total number of cards are 5. 1 by 5 is the probability of getting a queen. Next, if the queen is drawn and put aside, if the queen is removed or drawn, then the total number of cards will be remaining 5 minus 1 gives us 4 because that kept aside, queen kept aside. So in that first one, probability of getting after removing, second card picked up is an ace. Probability of getting an ace is equal to number of favorable outcomes divided by total number of outcomes. So ace is only 1 divided by 4. So in this case, total number of cards will be 4 because queen taken out means kept aside, drawn and kept aside. So 1 by 4 will be the probability of getting an ace. Now second question is probability of getting queen. Queen in first case only kept aside means removed. So number of favorable outcomes divided by total number of outcomes. Here no queen because already removed, it gives us 0. It is nothing but what? Because queen is removed first, already removed. So here probability of getting queen gives us 0, or this is an impossible event because there is no queen in the set of those cards that kept aside already. So the probability of getting queen gives us 0 in this case. So we have to write all these in your 16th question from exercise 15.1. Total defective pens means not working properly, not working pens are accidentally mixed with 132 good ones. Accidentally means without knowing. Mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective. Just by seeing, we can't say this is a good one, this is a defective one. Okay? One pen is taken out at random from this lot. Okay? So total defective and 132 good one. So one pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. So by seeing all those, total defective and 132 good ones. So mix it over. One pen is taken out. What is the probability that the pen taken out is a good one? According to the given question, it is given that number of good pens 132, number of defective pens 12, total number of pens 144. Now probability of pen taken out is good one, that is equal to number of favorable outcomes or number of outcomes favorable to E divided by total number of outcomes. See, number of favorable outcomes are nothing but what? Good pens are 132. 132 divided by total number of pens are 144. Simplify this one. It is divisible by 12. 12 ones pens 144. Out of 144, what is the probability of getting taken out pen is good one. So good pens are 132 divided by total number of pens are 144. That gives us 11 by 12 is the probability according to the given question. Now we'll discuss 17th question from exercise 15.1. In that first one, a lot of 20 bulbs contain 4 defective ones. A lot contains 20, out of 24 bulbs are defective, means not working properly. One bulb is drawn at random from the lot. One bulb is taken. Okay. What is the probability that this bulb is defective? Means it is not working. Question is, what is the probability that this bulb is defective? This is first question. 17 in first one. Total number of bulbs 20. Number of defective bulbs 4. Therefore, number of good bulbs 20 minus 4 gives us 60. Now, probability of getting defective bulbs is equal to number of favorable outcomes or number of outcomes favorable to E divided by total number of outcomes. Number of defective pens or bulbs are 4 by 20. That gives us 1 by 5. 1 by 5 is the probability of getting defective bulbs. Now, second question is, suppose the bulb drawn in one is not defective. It is nothing but not defective means good, and is not replaced means not replaced as it is kept. Now, one bulb is drawn at random from rest means remaining. Okay? What is the probability that this bulb is not defective? This you have to understand. So the question, suppose the bulb drawn in one first question is not defective. Here, getting defective bulb, if it is not defective and is not replaced means kept as it is. If it is not defective, kept as it is only. Now, one bulb is drawn at random from rest, means from remaining. What is the probability that this bulb is not defective? Means this is not defective. Probability of getting defective will count. Probability of getting not defective if it is not defective. See, question, solution. In 20 bulbs, one bulb is removed. Why removed? Because kept as it is. Assume, suppose it is not defective. Therefore, total number of bulbs remaining is equal to 20 minus 1 is equal to 19. 20 minus 1 is equal to 19 bulbs will be remaining. Therefore, probability of getting bulb drawn is not defective is nothing but number of favorable outcomes. So, number of good bulbs 16. There one we have to remove because one bulb should be removed. In total number of bulbs, one removed, and in total number of good bulbs also one you have to remove. That gives us number of favorable outcomes divided by total number of outcomes 15 divided by 19 because total number of bulbs or number of defective bulbs 4, number of good bulbs are 16. One you have to remove there, that gives us 15, and in total also you have to remove one, that gives us 19. So 15 by 19 is the probability of bulb drawn is not defective. A bit confusion here. Try to understand. Read this question and understand according to the question, and you have to write the solution. Now we will discuss 18th question from exercise 15.1. A box contains 19 discs which are numbered from 1 to 19. A box contains 19 discs which are numbered from 1 to 19. If one disc is drawn at random from the box, means without looking into it, find the probability that is bears. First question, a 2-digit number. Second question, a perfect square number. Third one, a number is divisible by 5. These are the 3 questions by using the given information you have to write. Total number of discs are 90. Total number of discs are 90. Number of 2-digit numbers is equal to 90 minus 9, that gives us 81. because 1 to 9 are single digit number. Next 10 to 90 are 2 digit numbers. So 90 numbers minus 9 gives us 81 are 2 digit numbers. So the probability of getting a 2 digit number is equal to number of favorable outcomes or number of outcomes favorable to E is nothing but what? E divided by total number of outcomes. So total number of outcomes, number of favorable outcomes are 81 divided by 90. 9 9s are 9 10s are 9 by 10 is the probability of getting a 2 digit number. A 2 digit number. Next, perfect square numbers. The probability of getting a perfect square numbers. Before that, you have to write how many perfect square numbers are there from 1 to 90. Perfect square numbers from 1 to 90 are 1, 4, 9, 16, 25, 36, 49, 64, 81. 90 is not a perfect square number. So up to here you have to write. These are the perfect square numbers from 1 to 90. Those are 9 numbers. So the probability of getting a perfect square numbers or perfect square number is equal to number of favorable outcomes or number of outcomes favorable to E divided by total number of outcomes. That gives us 9 by 90. 9 by 90, 9 ones are 9 tens are. 1 by 10 is the probability of getting a perfect square number. Now come to third question from this thing only. A number divisible by 5. How many numbers are divisible by 5 from 1 to 90? We have to write first. Numbers divisible by 5 up to 90 are given. See 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. These are the numbers divisible by 5. So total 18 numbers are divisible by 5 from 1 to 90. So the probability of getting a number divisible by 5 is equal to number of favorable outcomes or number of outcomes favorable to E divided by total number of outcomes. That gives us 18 numbers are divisible by 5. So 18 divided by 90, 18 ones are 18 5s are 1 by 5 is the probability of getting a number divisible by 5 by using the given information. 1 to 90 discs are there. So by using that information, you have to write these three questions. You have to answer for these three.